things. He is the originator of the heavens and earth. When he decides on something, he just says to it, "Be," and it is. In the same way that structures that cannot be reduced to a simpler form demolish the claims of the myth of evolution, the fine detail they possess reveals to us, with the most striking examples, God's artistry and matchless intellect. The signs of creation in living things have now become a scientific concept and are supported against Darwinism by the world's best-known scientists. Among the most prominent names in this movement are those of Philip Johnson from the University of California at Berkeley, William Dembski from MIT, Chicago, and Princeton universities, Stephen C. Meyer, who earned his PhD from Cambridge University, and Paul Nelson from Chicago University. As well as maintaining that life did not come into existence by chance, and that God created all living things, these scientists hold seminars and conferences all over the world. Another organ that cannot be reduced to a simpler form is the ear. The human ear consists of several components, and hearing is the result of all these working in harmony together. A deficiency in any one of these components means that a person either becomes deaf or else suffers severe hearing difficulties. Brief details of how hearing actually takes place will enable us to understand how complex the process is, as well as the sensitive balances on which it is constructed. As we know, hearing begins with vibrations moving through the air. These vibrations are reinforced in the auricle. In this way, the intensity of the sound waves is amplified by approximately 17 decibels on entering the outer ear, from where the sound vibrations reach the ear membrane. The ear membrane is so sensitive that it can perceive vibrations of the dimensions of a single molecule. It is thanks to this sensitivity that in a silent environment we can hear someone whispering from many meters away. The ear membrane enhances the vibrations reaching it and transmits them to the middle ear. Here, there are 3 small bones in contact with one another in a very sensitive balance. These 3 bones, known as the anvil, hammer, and stirrup, enhance the vibrations reaching them from the membrane. The mechanical movements we have described so far began turning into sound in the region known as the inner ear. The inner ear contains a liquid-covered organ known as the cochlea. The final component of the middle ear, the stirrup, is connected to a membrane on the entrance to the cochlea. Mechanical vibrations in the middle ear are transmitted to the cochlea fluid by means of this membrane. The vibrations reaching the inner ear set up a wave action in this fluid. The inner walls of the cochlea are lined with small hair-like structures, which are in turn affected by the wave movements in the fluid. These tiny hairs move according to the wave motions in the cochleal fluid. If a loud noise arrives, most of these hairs move, and in a more powerful manner. Every sound frequency in the outside world sets up different reactions in these hairs. Fine, but what does the movement of these hairs signify? What possible connection can these hairs in the cochlea in the inner ear have with our listening to a classical music concert, recognizing a friend's voice, hearing the sound of a car, and distinguishing millions of other sounds? The answer to that question once again shows the magnificent complexity of the ear. Each of these tiny hairs is actually a separate mechanism located on 20,000 or so individual cells surrounding the inner wall of the cochlea. This movement opens the ion channels in the cells lying beneath the hairs and permits the entry of ions into them. When the hairs lie back in the other direction, the cell doors close. This constant motion constantly changes the cell's chemical balances and allows them to produce electrical impulses. These electrical impulses are transmitted by nerves to the brain, where they are interpreted and converted into sound. Science has not yet unraveled all the technical details of this system. In producing these electrical signals, the cells in the inner ear manage to reflect the frequency, force, and rhythm of the waves from the outside world. This is such a complex process that science has not yet been able to determine whether the process of distinguishing frequencies takes place in the inner ear or in the brain. All the information we have considered so far shows that our hearing organ, the ear, possesses an extraordinary complexity. Close consideration shows that it has an irreducibly complex structure, because in order for hearing to take place, a great number of independent components need to exist together, fully and perfectly formed. If just one of these is removed from the ear, or else suffers a structural defect, then one will no longer be able to hear anything. In order for the ear to hear, such different elements as the external ear membrane, the anvil, hammer, and stirrup bones, the cochlea, and the tiny hairs inside it, all have to exist in perfectly functioning form. The system cannot develop in stages, because none of those stages on their own will serve any purpose. To suggest that an organ as complex as the ear was built in stages by a random process such as evolution is both unscientific and irrational. Organs possessed of irreducible complexity in living things, such as these, totally undermine the theory of evolution. They also reveal the fact that we are created by God. This same truth is revealed in one of the verses of the Quran. Say, it is He who brought you into being and gave you hearing, sight, and hearts. What little thanks you show. At the point we have arrived at today, science shows that life was created and reveals to us the omniscience of our Creator, Almighty God, the Lord of all the worlds.